Hello everyone, this is How I Love Geometry. I'm Mr. Cao. This problem is from 2018 Aime 1, problem number 15. Davy found 4 sticks of different length that can be used to form 3 non-congruent convex cyclic quadrilaterals A, B, C. Cyclic quadrilaterals means all these 4 sticks are on the vertex. All of them are on a same circle, like this one. For example, if I say this side is A, this side is B, and this side is C, and this side is D, that's the diagonal. If I say this is D1, and this diagonal is, for example, here is A, B, like the vertex A, B, C, D. So this is diagonal is D2, right? Okay, that's just one of the ABC, which can each be inscribed in a circle with radius 1. So the radius of this circle, radius is 1. Let phi A denote the measure of the acute angle made by the diagonals of quadrilateral A. So D1 and D2, and this angle, let us say, is phi A. Okay? Yeah. And define phi B and phi C similarly. Suppose that sine phi A equals 2/3, sine phi B equals 3/5, and sine phi C 6/7. All 3 quadrilateral have the same area K. So the area for this one is K, which can be written in the form, the area K can be written in the form M over N. Finally, we should find M plus N. So at the beginning, I want to find some basic formula or theorem or some relationship between all of this side of cyclic triangles and all diagonals of the area. What's the relationship between them, right? Because we know the Ptolemy's theorem. Ptolemy's theorem. For this diagram, we got D1 times D2 equals AB plus CD, right? Yeah, I will use this part because this problem may be too complicated and we need a lot of space. So D1 times D2, we got AB plus CD. We know the area for this ABCD. First, we can get the area of ABD, right? According to the sine law, we know the sine law, right? We can use 1/2 times A times D, right? 1/2 times A times D and times the sine angle BAD, right? And we know, then we can go ahead 1/2 AD sine BAD, we know according to the sine law, D1 over sine law, over the sine this angle BAD, equals 2R, right? We know this one. That's the sine law tell us. So now we can use this one d1 over 2r to substitute this sine angle BAD. So it times d1 AD times d1 over 2r, right? That's 1/2 times this. So it will be AD d1 over 4r. So we can get the area, not just the ABD, we can get the area triangle BCD. We can imagine is the same thing of here is 4r and BC times d1, right? So the area ABCD equals this, the area of this triangle plus the area of this triangle. So we got to put them together. So that all of them have d1 over 4r then times which one? AD plus BC, right? Okay, that's the first conclusion we can get. And then we will change it to another way to do the same thing. The area for ABC, triangle ABC, and according to this one, we will get the same thing for 4r AC D2, right? CD2. And the area of BCD also similar. So that we will get is BD, right? That's AC. Now we got BD. BD D2, right? BD D2 over 4R. So use another way to get the area ABCD. ABCD equals the area of this triangle plus this triangle. Put them together, we will get the same D2 over 4R times AC plus BD. Okay, now we got this conclusion, right? And we can go ahead for this one. And because let us say the area for ABCD, if I say this equals K, then we times this area, this form, and this equation. Then we will get K squared equals, so D1 times D2, so you see here D1 times D2, and denominator is 4R times 4R, so is 16R squared, and then times this one, AD plus BC times this one, AC plus BD, right? And for the Ptolemy's theorem, we know D1 times D2 equals AB plus CD, so we will get this one, got AB plus CD, that's D1 times D2, then times AB, now I use this one, times AC, in order AB, AC, then AD, AC plus BD, then times AD plus BC, right? Okay, we will got, now we got this one, the square of the areas for ABCD, it squared equals to this one, and over 16R squared, and we can write like this equation, right? We got this. Okay, next step, we will got another relationship, and then we can use it for this one. relationship between them, because this problem tells us this angle, right? And we will find how to use this angle to express the area of ABCD. So let me draw this one like here. This is a circle. Then it's not, it may not be, not necessarily to be the diameter. I just want to show, to got the formula. So for if this is A and this is B, I mean this, and this side is C and this side is D, and this is the angle. For example, for this problem, we can use phi C, right? Okay, no problem. Then this diagonal, this part, W, X, and this one is Y, and this is Z. And finally, we will find the relationship between them. Okay, we know K equals, I mean the area A, B, C, D, I mean this one. So it's equal to the area of this small triangle, that's 1/2 WX times sine, this is phi C, this is also phi C, sine phi C, then plus 1/2 of x y, right? Here is y, and times this one, sine 180 degree minus phi C. So this sine this one equals to this one, right? We know the basic knowledge about the trigonometry. And then plus the area of this one, 1/2, that's YZ sine phi C, then plus 1/2 of this one, this area. So 1/2 ZW sine 180 degree minus phi C. So all of them have 1/2 and sine phi C. That's sine phi C, where is the phi C is times 6/7. Okay, then what's that? WX plus XY plus YZ plus ZW. We can write down this and this. So that's 7/3/7. Then what we will write down? W, we can factor out this W and X plus Z. So here factor out Y, also X plus Z. So we've got W plus Y, then times X plus Z, right? WX, WZ. So this one and this one. Now YX, this one, and YZ, so this one. We know W plus Y. W plus Y is D2, right? And X plus Z is D1. So it means equals 3/7 times D1 times D2, right? Now we will got which one? D1 times D2 we know, and we will got times, so it's this each side times reciprocal of this number, 7/3 K equals D1 times D2. We use Ptolemy's theorem, right? We equals AB plus CD, right? Yes. If we got this, yeah, here we just almost, we know that this is a formula, that I mean K equals like here we just got, that's 1/2 times sine phi, then times d1, d2, right? So this diagonal times the length of this diagonal, then times sine phi times 1/2, it will be the area of this cyclic quadrilateral. That's, yeah, also we got this. So then next step we can use this same way, just change it to change the different, here is the phi c, then we will use the phi b, phi a, right? And then we will got this one, 3 times k equals AC plus BD. And also we got 3k equals AD plus BC, right? Now we got all of this 3, then we can times all of this, correct? We can times all of this. We will got k cubic, right? And this times, what's this? 3 times 3, so it's this 3 and this 3 just cancelled. We got 70 over 3, 7 times 10 over 3, 7 times k cubic equals this one. AB plus CD times AC plus BD and times AD plus BC. So, and this equals how much? Equals 16r squared k squared. 16r squared, right? 16r squared times this k squared. We know r is 1 here. The radius of this circle is 1, so is 16 times k squared. Now each side we can cancel k squared, then k was left. So 3/73 k equals 16. Then we got k equals 3 times 16 over 70. So that's each side divided, top and bottom divided by 2 is 824 over 35. This is the k, 24 over 35. So the final answer, we got m plus n, right? M plus n. So 24 plus 35. So equals 59. Yes, well done. This problem is a little hard because we should know a lot of basic knowledge. If you, before you solve this problem, if you know this formula and this formula, it will help us a lot. But if we don't know this, we should try to get this before we really can solve this problem. And finally, I think we should have a very strong basic knowledge about the how to calculate the area, how to use the Ptolemy's theorem, and how to use it all of them smartly. Yeah, finally we will find the final answer. And because we can just group the main idea about the relationship of the area and the size and the circles, angles of this type of problem. Okay, hope you enjoy it. Thank you. I hope we can meet for the next problem.